My name is Adriana, and in the next few minutes I will show you all there is to know about net ionic equations. Net ionic equations depict the dissociation of ions and shows the process of a salt dissolved in a water in order to create an aqueous solution. Here's what you need to know ahead of time. Make sure to be familiar with balancing equation, polyatomic anions, and solubility rules. For balancing equations, we know to make sure all moles of the elements match on both sides of the equation. So, if there's a reaction where iron 3 oxide decomposes into solid iron, add the coefficient 2 in front of the singular iron. Make sure to know the most common polyatomic anions, including nitrate, chromate, and chlorate, and their formulas. Solubility rules will become especially important when learning net ionic equations. Remember, NAG-SAG. Nitrates, acetates, group 1, sulfates, ammonium, and group 17 elements will always be soluble, with the exception of lead, mercury, and silver. There's two different types of ionic equations. The complete ionic equation shows each aqueous solution separated into their ions. The net ionic equation is a simplified version of the complete ionic. This is where all of the spectator ions are cancelled out. Now, finally, here's how to derive net ionic equations. First, balance the molecular equation. All of the moles must match up. Next, assign states of matter using solubility rules. All of the aqueous solutions should be separated into their correlating ions, and to get the overall net equation, cancel out all the spectator ions. Your final equation should look something like this. In the original molecular equation, sodium hydroxide was the salt being dissolved in sulfuric acid, forming sodium sulfate and water. In the net ionic equation, you can see the synthesis reaction happening between the hydroxide ions and the hydrogen ions to form water. And now, you're ready to take on any net ionic equations this year. You got this.